Welcome to Section 5A. We're moving into a new unit called Statistics. Statistics has two definitions. The first is the science of collecting, organizing, and interpreting data. The other definition is data that describe or summarize something. So the first one is the actual actions, and the second one is the conclusion or the results of the actions. The first thing about statistics is population. This is the complete set of people or things being studied. Population parameters are the characteristics of the population that will be measured. The sample is a subset of the population where the data is obtained. Sample statistics are the summary of the raw data. So if I have my bag of potato chips over here and I want to know if it's gone bad, my population to define the complete set of things or people or things being studied will be all of the potato chips within this bag. The population parameters, or the characteristic that I'm measuring, is the staleness of the potato chips. The sample is the subset of the population, so I would probably take maybe 3 chips out and determine and test if they are stale or not. The sample statistic would be if they are stale or if they aren't. So if I sample the 3 chips and they're stale, my sample statistics are all 3 chips are stale. Let's move on to finding these same definitions within some more statistical studies. Our first example is an agricultural inspector for Jefferson County measured the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn-producing farms in the county. The first thing we need to find is the population. The study is in Jefferson County, so it will be all of the ears in Jefferson County and not beyond. The population parameter are the levels of residue on all of the corn, and the sample will be the 25 ears that they collect. The sample statistic is the collected residue levels from the 25 ears gathered. Let's try another one together. Anthropologists determined the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe. Okay, the population. This is all the people or things, a complete set. So ours is the Neanderthals in Europe. The population parameter, what are we looking for? It says determining the average brain size. So our population parameter is the brain size of the Neanderthals. We could go further and say Neanderthals in Europe, but that's good enough for now. The sample will be the skulls that we collect from the 3 different sites. And the sample statistic will be what we get for the average brain size of the skulls that we collect. There we go. Let's move on. The process of a statistical study. The first thing we need to do is identify the goals, and then draw a sample from the population, and it needs to be representative of the population. Then collect all the raw data and summarize. Number 4, make inferences about the population. And number 5, draw conclusions. So my first is going to be kind of nice, breaking us in. We want to find out how many LDS people have a 72-hour kit ready. So the goal of my study is to find out how well the LDS people who are prepared for emergencies. So I'm going to draw a sample. My sample needs to be LDS families, so I'm going to choose 1,000 LDS families. Number 3, collect the raw data. So of these 1,000 families, I'll either ask or survey or some sort of way to collect the data and then summarize. So of these 1,000 families, I find the percent who are prepared for an emergency, and let's just say we have 375 who have a 70-hour kit, 72-hour kit. Then I make inferences. So I use the information I got from the collecting stage to describe the preparedness for all LDS families in emergencies. So if I have 375 families out of the 1,000, my sample was that 37.5% of families have 72-hour kits. So therefore, I take that and I infer that of all LDS families, only 37.5% of them have 72-hour kit and are prepared for emergencies. And then I make my conclusion. Either I have few or most LDS families who are prepared. If this was correct, then I would say that the LDS people need to be more prepared for emergencies and preparing their 72-hour kits. Now we're going to get into choosing samples. There's different ways to choose samples. You want to make sure that it is representative of the population. If I were to take a sample that isn't about the population, then the whole study goes awry. So with my study here, I needed to choose 1,000 LDS families. If I just chose 1,000 people out on the street and then made my inferences about LDS people, then it wouldn't make any sense. All right, so the first example is, or way to choose a sample is simple random. This is when every person in the population has an equal chance of being picked, such as choosing from a hat. The second way is systematic. This is if you are using some sort of a system to select each person. So if I make a huge long list and then I take every nth person, like every fifth person, every 400th person. The next option is convenience. This just means that it's convenient to select. So if you're just out on the street, you just keep asking people who walk by you. And the last one is stratified. This is a simple random. Remember, simple random's like choosing from a hat, but within subgroups of a population, such as if I'm drawing names of men and women. So I have my subgroups of men and women, and then I do a simple random of the men and a simple random of the women. If I were to do a stratified with my LDS example, I would probably divide my subgroups by countries and then draw random names from each country. All right, here's a couple of examples and we're going to label them. If I have a dormitory and I'm knocking on every 10th door, is that simple random, systematic, convenience, or stratified? In this case, because it's every 10th door, it's systematic. Number 2. Oh, and let's highlight that to be the answer, or highlight in some form. Number 2, we want to find the opinions of property tax. So we randomly draw 150 homeowners from a public list. Because it's random and everyone had the same chance of being drawn, this is a simple random. And highlight the answer so we can find it quickly. Number 3, Jefferson County inspectors check levels of pesticide residue on corn from 25 ears from 104 corn-producing farms. So I have 104 corn-producing farms and 25 ears from each. This one is stratified. I have divided up my population into subgroups, which will be the farms, and then within that, 25 random ears of corn. Number 4, anthropologists measured the brain size of Neanderthal skulls from 3 sites in southern Europe. For some of you who may not know where Neanderthal skeletons have been found, here's a quick map. So if I want to find the brain size of Neanderthal skulls in southern Europe, they seem to be kind of spread out. So this one is convenience. Convenience because they are all close together. All right. A quick little note, the definition of bias is when you favor certain results. In the next section, we'll go into different ways of bias, such as sampling bias and participation bias. Okay, Roman numeral 3, types of a statistical study. There's the observational study, and this is where you measure characteristics but you don't influence the results in any way at all. An experimental study is where you apply a treatment on sample members and see the effects. But you must have two groups, the treatment group and the control group. The treatment group receives the treatment and the control group receives no treatment so that you can compare the differences. A placebo lacks active ingredients, but it appears the exact same as a treatment. The placebo effect is where patients experiment treatment-like symptoms just because they think they're getting a treatment, so it's all in their mind. Blinding. This is where participants don't know which group they're in, versus the control versus the treatment, and you can use a placebo to help in the blinding process. There's two different types of blinding, the single blind and the double blind. A single blind is where participants don't know which group they're in, but the experimenters know which group. A double blind is neither the participants nor the experimenters know which group, and some people don't know how that would work. So if I were to have a group of people taking some sort of a treatment, and I have the cups lined up, and on the bottom of the cup I might have some sort of a marking of it being a placebo or a treatment, and then I mix up the cups as the experimenter and then hand it to the participants and just note which participant has which cup, and at the end I can then look and see which participant was in the placebo group and which one was in the treatment group, and that's how you would have a double blind, or different other examples. All right, let's move on to this statistical study about chiropractors, and I want you to be observational about what's going on. Is something wrong with this study, or is it good? Can I take the information and the conclusion as being fact? So the question is, can going to a chiropractor relieve back pain? 25 patients with back pain have adjustments. 18 of the patients feel better after the adjustment. So we conclude that adjustments are effective. Is there anything wrong with this? Well, first of all, they're going to a chiropractor, so what kind of study is it? Well, it's not observational because that's where you can't influence things. This means I'm experimental. And I have a treatment group, the people who are receiving an adjustment. But there's no control group, so I can't compare. If I were to have a control group of 25 patients with 18 of them also feeling better, maybe a day later, then there's no difference between the groups, and I can't make my conclusion that adjustments are effective. I must have a control group. And a lot of studies out there that say new studies show often have some sort of problem going on in the study. All right, let's move to the next one. Let's say that this drug for ADD makes children polite. So let's go through everything together. A simple random selections of children with ADD are put into a control group and some in a treatment group. Well, so far so good. We know that it's experimental and I have two groups. The control group is given a placebo and the treatment group is given the new drug. Okay, so one is receiving treatment and the other is not. It's a single blind study. Oh, so now we even have a blind, and it's single blind where the participants don't know, but the experimenters do. And the experimenters interview the children to see if they are more polite. Is anything wrong with this? It sounds pretty legit. We have a treatment group, a control group, a placebo, it's even blinded. However, we have an interaction between the experimenter and the children, and the experimenters know which are in which group. And so, oh, there it is. It needs to be a double-blind experiment because there's an interaction between the two, and they might somehow, whether on purpose or not, influence the results and think or produce some sort of results of them being more polite versus the placebo group. There's actually one more study. It's called case control. It's an observational study. Now remember, observational means that you don't influence, you just measure the characteristics. It's an observational study, but it looks like experimental because the samples naturally divide into groups. The groups are those who engage in a behavior, they're called the case, and those who don't engage in the behavior, and they're called the control. So it's a case control study. Remember, it's observational. And these are things like people who smoke versus people who don't. It's observational, and you just find the results between the two groups that have naturally divided. And I was going to take these out. What is the average income of stockbrokers? This is just observational. We aren't going to do anything experimental in finding out the average income. Ignore the answer on the next one that I'm going to scroll down to. Do seatbelts save lives? Am I going to do an experimental study on seatbelts? Absolutely not. We would never ask somebody not to wear a seatbelt. Something like this, an experimental study, you could do with crash test dummies. So this is a case control where you find people who have and those who haven't, and unfortunately examine crashes where people have lost their lives versus those who have been saved by their seatbelt. The next one, lifting weights improves running time. Well, it's not a case control, although some of them might divide naturally. I could do an observational, but that's really case control because you could have some people who naturally do. But I really want to know if it improves running time. So I'm going to take very specific people and make an experimental study. So I have my people who are lifting weights and timing their running time, and those who aren't lifting weights and timing their running time. And this one, it can't be blinded because you have the two groups and you're going to see those who are lifting weights, and you're also going to see the results. So even if they were hiding in a room, you could still see the results of those who are lifting weights. Oh, and one more. An herbal remedy reduces cold severity. This one, you would need to have a double-blind experiment because you would have some sort of interaction between the experimenter and the participant to see how their cold severity is coming along. Number 4, surveys and opinion polls. The first thing we need to go over is margin of error, and I always abbreviate this as MOE, M-O-E, margin of error. In a 95% confidence interval, the margin of error is that teeny bit of wiggle room to say, oh, give or take about 5 people, or give or take about 3%. A confidence interval is the range of values that most likely contain the true population parameter. Wait a minute, we talked about population and sampling and sample statistic. So what's going on with this true population parameter? Remember with my potato chips up here, the sample was the summary of the raw data, the actual potato chips that were stale. The population might not all be stale. So the true population parameter right here might not be that all the bag is stale. There might be some that aren't. So it's that range where it most likely is correct. A confidence interval is calculated by taking your sample statistic. So if 75% of the chips that I tested were stale, and then that's my sample statistic, I add a little bit of wiggle room, so give or take some chips that may or may not be stale also, and that's my confidence interval. So let's move to our example to make it a little bit more solidified. An election poll finds that 52% of surveyed voters plan to vote for Smith. The margin of error is 3 percentage points. Smith needs to win by more than 50%. Find the confidence interval and interpret the results. So the confidence interval takes our sample statistic. We found that we didn't survey the entire population. So this was a poll. So my sample was 52% of them plan to vote for Smith. That's a sample statistic. The margin of error is 3 percentage points. So I need to add and subtract the margin of error to the sample statistic. So 52 plus and minus 3%. Subtracting gives me my lower percentage of 49% and the upper percentage of 55%. To write it in interval notation, you go from lower to upper with parentheses and a comma in between. I've seen a lot of people turn in work with the upper down here and the lower up here. Just like numbers go from low to high, and reading from left to right, this should also go from low to high. So my confidence interval says that from about 49% to 55%, we are sure of this percentage that Smith will have the vote. But he needs to win by more than 50%. That's really close. In fact, two of the percentages are that he won't win, 49 and 50%. And the true population needs to be within here because our sample was only a poll. That means it's really too close to say if he's going to win or not. Another way of interpreting it is we can state we are 95% sure, because this is a 95% confidence interval, that the actual number of voters, now it's not the full number because we did the poll, are going to that will vote for Smith is between 49 and 55%. But it's really too close to call because it's right there around 50, so we can't say for sure that he will get the vote or not. All right, I'll see you for the next section.